The National Electrical Code specifies the minimum voltage allowed for residential use. For 120-volt circuits, the minimum allowed voltage is 115 volts alternating current. For 115-volt circuits, the minimum allowed voltage is 110 volts alternating current. A reading of 100 volts at the panel is below the NEC minimum. This can cause several problems. Firstly, it can cause dimming or flickering lights. Secondly, reduced appliance performance is possible. Thirdly, motor damage may occur. Fourthly, safety hazards, such as an increased risk of electric shocks, can arise. Several troubleshooting and resolution steps can be taken. Firstly, check the main breaker to ensure it is fully engaged and providing sufficient power. Secondly, inspect the wiring for loose connections or damaged wires, which can cause voltage drops. Thirdly, contact the utility company to investigate potential issues with the power supply to the home. Fourthly, consider installing a voltage regulator to boost the incoming voltage to an acceptable range. It is important to address this issue promptly to prevent potential damage and hazard. Addressing voltage drops requires a systematic approach. Firstly, begin by verifying the voltage at the point of entry, typically the main service panel. A reading significantly below 120 volts indicates a potential problem with the utility supply or the service entrance wiring. Secondly, check the main breaker in the panel. Ensure it is properly seated and not damaged. A loose or faulty breaker can impede the flow of electricity. Thirdly, examine the wiring connections within the panel. Look for any signs of corrosion, looseness, or damage. Tighten any loose connections and replace any damaged wiring. Fourthly, if the voltage at the service panel is within the acceptable range, investigate the branch circuits. Use a voltmeter to measure the voltage at various outlets and fixtures. A significant voltage drop between the panel and the outlet indicates a problem with the branch circuit wiring. Fifthly, inspect the wiring along the branch circuit. Look for loose connections, damaged insulation, or undersized wiring. Replace any faulty wiring with the correct gauge wire. Sixthly, consider the load on the circuit. Overloading a circuit can cause voltage drops. Reduce the number of appliances or devices plugged into the circuit. Seventhly, if the voltage drop is isolated to a specific appliance or fixture, check the wiring and connections within the appliance or fixture itself. Faulty wiring or connections can cause voltage drops. Eighthly, if you are unable to identify and resolve the voltage drop issue, consult a qualified electrician. They have the expertise and equipment to diagnose and repair electrical problems safely and effectively. When dealing with electrical systems, safety is paramount. Firstly, always disconnect the power supply before working on any electrical wiring or components. Secondly, use insulated tools and wear appropriate personal protective equipment such as safety glasses and gloves. Thirdly, never work on electrical systems in wet or damp conditions. Fourthly, if you are not comfortable working with electricity, consult a qualified electrician. They can perform the necessary repairs safely and effectively. Understanding voltage drop is crucial for maintaining a safe and efficient electrical system. By following these troubleshooting steps and taking appropriate safety precautions, you can identify and resolve voltage drop issues, ensuring that your electrical system operates optimally. Several factors can contribute to low voltage in a residential setting. Firstly, distance from the transformer plays a significant role. The farther a home is located from the utility transformer, the greater the potential for voltage drop due to line impedance. Secondly, the gauge of the wiring used in the home's electrical system impacts voltage levels. Undersized wiring can lead to excessive voltage drop, particularly when multiple appliances are in use simultaneously. Thirdly, loose or corroded connections can impede the flow of electricity, resulting in lower voltage readings. These issues can occur at various points, including the service panel, outlets, and light fixtures. Fourthly, high electrical demand within the home can strain the system and contribute to voltage drop. This is especially common during peak usage times, such as evenings when multiple appliances and lights are in operation. Fifthly, problems with the utility company's equipment, such as a faulty transformer or damaged power lines, can also cause low voltage issues in the home. Diagnosing the root cause of low voltage requires careful investigation. Firstly, begin by measuring the voltage at the service panel using a reliable voltmeter. This will establish a baseline reading and help determine whether the problem originates within the home or with the utility supply. Secondly, check the voltage at various outlets and fixtures throughout the house. Significant voltage drops between the service panel and these points indicate potential wiring issues or overloaded circuits. Thirdly, inspect the wiring connections at the service panel, outlets, and fixtures. Look for loose connections, corrosion, or damaged wiring. Tighten any loose connections and replace any damaged wiring. Fourthly, consider the age and condition of the home's electrical system. Older homes may have outdated wiring that is more prone to voltage drop. In such cases, upgrading the wiring may be necessary. Fifthly, if the low voltage issue persists, contact the utility company to request an inspection of their equipment. They can identify and address any problems with the transformer or power lines that may be affecting the voltage supply to the home. Addressing low voltage is essential for ensuring the safe and efficient operation of electrical appliances and equipment. Firstly, low voltage can cause appliances to operate inefficiently, leading to increased energy consumption and reduced lifespan. Secondly, it can damage sensitive electronic devices and increase the risk of electrical fires. Thirdly, it can create a safety hazard, increasing the risk of electric shock. To mitigate low voltage issues, consider the following measures. Firstly, upgrade undersized wiring to a larger gauge to reduce voltage drop. Secondly, install dedicated circuits for high-demand appliances to prevent overloading. Thirdly, use energy-efficient appliances and lighting to reduce overall electrical demand. Fourthly, have a qualified electrician inspect and maintain the electrical system regularly to identify and address potential problems. When working with electrical systems, always prioritize safety. Firstly, disconnect the power supply before working on any wiring or components. Secondly, use insulated tools and wear appropriate personal protective equipment. Thirdly, if you are not comfortable working with electricity, consult a qualified electrician. Low voltage in a residential setting can stem from various factors, necessitating a systematic approach to diagnosis and resolution. Firstly, consider the incoming voltage from the utility company. A significant drop in voltage at the service entrance indicates a problem upstream requiring the utility's attention. Secondly, evaluate the service panel's condition. Corrosion, loose connections, or outdated components can impede proper voltage distribution. Thirdly, assess the branch circuits. Overloaded circuits or undersized wiring can lead to voltage drops at outlets and fixtures. Fourthly, examine individual appliances. Faulty appliances can draw excessive current, contributing to voltage fluctuations. Firstly, ensure the main breaker is fully engaged and functioning correctly. A tripped or partially engaged breaker can restrict current flow. Secondly, inspect the wiring connections at the service panel. Look for loose connections or signs of corrosion, which can increase resistance and reduce voltage. Thirdly, check the grounding system. A poor ground connection can affect voltage stability. Fourthly, use a calibrated voltmeter to measure voltage at various points in the electrical system, including the service panel, outlets, and fixtures. This helps pinpoint the location of the voltage drop. Fifthly, consider the impact of heavy loads. Running multiple high-wattage appliances simultaneously constrain the electrical system and cause voltage to drop. Firstly, upgrade the service panel to accommodate increased electrical demand. Secondly, replace undersized wiring with larger gauge conductors to reduce voltage drop. Thirdly, install dedicated circuits for high-wattage appliances to prevent overloading existing circuits. Fourthly, use energy-efficient appliances and lighting to reduce overall electrical consumption. Fifthly, install a voltage regulator to stabilize voltage fluctuations. Firstly, contact the utility company to inspect their equipment and ensure proper voltage delivery. Secondly, consult a qualified electrician to assess the electrical system and recommend appropriate solutions. Thirdly, follow all safety precautions when working with electricity, including disconnecting power and using insulated tools. Low voltage can manifest in various ways, including dimming lights, malfunctioning appliances, and overheating electrical components. Addressing the issue promptly is crucial to prevent further damage and ensure safety. Firstly, voltage drop is the decrease in voltage that occurs along a conductor due to its impedance. Secondly, impedance is the total opposition to current flow in an alternating current circuit consisting of resistance and reactance. Thirdly, resistance is the opposition to current flow due to the material of the conductor. Fourthly, reactance is the opposition to current flow due to inductance or capacitance in the circuit. Fifthly, voltage drop is directly proportional to the current flowing through the conductor and its impedance. Sixthly, longer conductors have higher impedance, leading to greater voltage drop. Seventhly, smaller conductors have higher resistance, resulting in increased voltage drop. Eighthly, higher current loads cause greater voltage drop. Ninthly, voltage drop can cause appliances to operate inefficiently, overheat, and potentially fail. Tenthly, excessive voltage drop can also create safety hazards, such as increased risk of electrical fires. Firstly, use appropriately sized conductors for the intended load and distance. Secondly, minimize the length of conductors whenever possible. Thirdly, reduce the current load on circuits by using energy-efficient appliances and lighting. Fourthly, ensure all connections are clean and tight to minimize resistance. Fifthly, consider using a voltage regulator to compensate for voltage drop. Sixthly, the National Electrical Code specifies maximum allowable voltage drop for branch circuits and feeders. Seventhly, the NEC recommends a maximum voltage drop of 3% for branch circuits and 5% for feeders. Eighthly, exceeding these limits can result in inefficient operation and potential safety hazards. Ninthly, calculating voltage drop requires knowledge of the conductor's resistance, length, and current load. Tenthly, online voltage drop calculators can simplify this process. Firstly, voltage drop is an important consideration in electrical system design and installation. Secondly, minimizing voltage drop ensures efficient operation, prolongs equipment life, and enhances safety. Thirdly, consulting with a qualified electrician is recommended to address voltage drop issues. Firstly, understand the relationship between voltage, current, and resistance. Secondly, use Ohm's law to calculate voltage drop. Thirdly, consider the impact of conductor length and size on voltage drop. Fourthly, use appropriate wiring methods and materials to minimize voltage drop. Fifthly, regularly inspect and maintain electrical connections to prevent voltage drop. Firstly, a voltmeter is an essential tool for measuring voltage drop. Secondly, an ammeter is used to measure current flow. Thirdly, a wire gauge is used to determine the size of conductors. Fourthly, a circuit tester is used to verify the presence of voltage. Fifthly, insulated tools are essential for safe electrical work. Firstly, always disconnect power before working on electrical circuits. Secondly, wear appropriate personal protective equipment such as safety glasses and gloves. Thirdly, follow all applicable electrical codes and regulations. Fourthly, if you are not comfortable working with electricity, consult a qualified electrician.